always, sometimes never. This time we have let x and y be vectors that are both non-zero. And we want to look at x transpose y is equal to 0 if and only if x and y are orthogonal. In a way, we want to prove if this is true or false instead of always, sometimes, never, but it seems like it might be true. Well, first of all, let's figure out what this actually says. It's an if and only if. What does that mean? It means there are two parts to the problem. One of the things we want to know is it true that if x transpose y is equal to 0, that x and y are orthogonal? And another thing we want to know is if x and y are orthogonal, is it true that x transpose y is equal to 0? So there are two parts to this if and only if. That's exactly what the wording means. First of all, I'm going to look at if x and y are orthogonal, is it true that x transpose y is equal to 0? And I already know the answer to this. It's always true because we looked at this in homework 1.27 and we proved that it was always true. Next question, though, is if x transpose y is equal to 0 and they both are non-zero, is it then true that x and y are orthogonal? In other words, perpendicular, or that they form a 90-degree angle? Well, let's think about this a minute. What do we know from our last problem? We know that the cosine of the angle is the dot product of the vectors divided by the length of each of the vectors. Well, notice if they were orthogonal, then what we would have here is a 90-degree angle, which means that the cosine of 90 degrees is 0, which means that x transpose y is equal to 0. So clearly there was another way that we could have proven our homework 1.27 if we had already done 1.28. It's like a corollary for the last homework that we did. Does it work the other way? What if we know that this is equal to 0? What would that mean? Well, what that means is that the cosine of theta would have to be equal to 0. And if the cosine of theta is equal to 0, that would mean that theta is either a 90-degree angle or a 270-degree angle, or that the two vectors that we started off with, x and y, actually were perpendicular to one another. So that means that x and y are orthogonal if x transpose y is equal to 0. And it's always true, the if and only if is always true, that if x transpose y is equal to 0, if and only if x and y are orthogonal. There's one other thing, though, this piece about them both being non-zero. Well, we needed it even to make sense of our formula here, because if one of them was 0, then we would be dividing by 0, since the length of the zero vector is 0, so it wouldn't make any sense. On the other hand, we actually say that any vector is orthogonal to the 0 vector. So this is still true when one of the vectors is actually 0. It's just that we have limited our proof because we were worried about dividing by 0.